Under such alien skies, life might exist in ways we can't even imagine. Their world might be icy, mountainous, dry and sandy, or an endless sea. Only future exploration will tell. If life can survive the wrath of a red dwarf like Proxima Centauri, it might evolve in ways that showcase stunning diversity and adaptability. If Proxima B can host life, that would be a big deal. You see, red dwarfs are the most common stars in the Milky Way. It's estimated that among the 30 stars closest to Earth, about 20 are red dwarfs. That means life on planets orbiting these unremarkable stars might actually be the norm in the universe, and earthly life might be the odd one out. Still, for all we say, we haven't truly seen what Proxima B looks like. All our knowledge is like peering through frosted glass based on indirect clues and speculation. But here's the good news. Better eyes are on the way. The James Webb Space Telescope has the capability to analyze exoplanet atmospheres. Though observing non-transiting planets like Proxima B is a major challenge, hope remains. Another exciting project is Breakthrough Starshot, a plan to use lasers to propel swarms of microprobes directly toward Proxima Centauri, possibly by 2075. Sending humans would take thousands of years, but these tiny probes might get there in decades. In the near term, our best bet to get a clear view of Proxima B lies in a massive telescope currently being built on Earth, the Giant Magellan Telescope, GMT. It's said that once complete, its resolution could surpass even that of the James Webb by several times. It's expected to open its eyes around 2029. Scientists are eagerly waiting. By then, we may finally catch a glimpse of Proxima B, maybe even see a short clip of it orbiting its star, or analyze its light, to search for signs of life. So, in short, our closest cosmic neighbor has a story full of mysteries. The next few years will be exciting. We might soon get the answers that end the endless speculation. Is Proxima Centauri B a new world brimming with the potential for life, or just a desolate rock urging us to look farther into the stars? Hope this journey to Proxima B sparked your interest. Proxima Centauri B, often referred to as the closest second Earth to us. But what does it really look like? Today we're sending you on a mission, off to Proxima Centauri B to find out for yourself. Have you ever had that moment, gazing up at the star-filled sky, wondering, in such a vast universe, could someone else out there be watching us too? Honestly, up to this point, the Milky Way seems almost eerily quiet to us. We've yet to receive any kind of greeting from alien neighbors. But that doesn't mean it's hopeless. In fact, our search for life beyond Earth has only just begun to warm up. Think about it. Even within our own solar system, scientists are increasingly convinced that Earth might not be the only place where life has blossomed. Take Europa, one of Jupiter's icy moons, for example. Beneath its thick ice, there might be a vast ocean. Or Titan, Saturn's veiled moon, covered in dense, mysterious chemistry, inspiring scientists to imagine countless possibilities. So what about beyond the solar system? Could there be a planet out there brimming with life? And one day, could we actually visit it on a spaceship? Well, the answer might be closer than you think. This much talked about planet is similar in size to Earth and sits right in our cosmic neighborhood, orbiting the closest star to our sun, Proxima Centauri. Although it may be scorched daily by intense radiation from its own sun, this neighboring exoplanet remains our top candidate in the search for alien life. Now, Proxima Centauri itself is quite an interesting star. It's part of a triple star system with two main stars, Alpha Centauri A and B, both similar in size to our sun, tightly orbiting each other. Then there's a small, dim, long-lived, and relatively cool red dwarf. Its light is so faint you'd need a powerful telescope just to spot it. But right beside this tiny star, astronomers made a stunning discovery. At least 3 planets have been found, 2 of which are confirmed. Among them, Proxima Centauri B lies in what we call the star's habitable zone. This region is typically defined by temperatures that allow liquid water to exist stably on a planet's surface. When Proxima B was discovered in 2016, it created a huge buzz. Everyone's curiosity was instantly ignited, not only because of its location, but also because its size and mass are similar to Earth's. People speculated that it might be a rocky world much like our own. There were bold hopes. Could it have air, water, maybe even life? However, romantic imagination quickly collided with harsh reality. The more scientists studied it, the more they realized that while Proxima B is Earth-like in some ways, its life path is vastly different. Proxima Centauri is a low-mass red dwarf star with a diameter only about 14% that of our Sun and far less heat output. What does that mean? Proxima B has to stay very close to its little sun to keep warm, over 20 times closer than Earth is to the Sun. As a result, it completes one orbit in just 11.2 Earth days. Birthdays on Proxima B would come around really fast. You might think a smaller star means a gentler temper, right? Quite the opposite. Despite its size, Proxima Centauri is extremely volatile. Red dwarfs often unleash massive solar flares, much more frequently and intensely than our Sun. That's because their convection zones reach deep into their cores, stirring up intense magnetic activity at the surface. This means Proxima B is bombarded daily with cosmic rays and particle storms, many times stronger than what Earth faces. And it doesn't stop there. Proxima B is likely tidally locked to its star, just like how the Moon always shows one face to Earth. It always presents the same side to Proxima Centauri, and the other side is always in darkness. This tidal locking creates a permanent day side and a permanent night side. The side facing the star must endure constant heat and radiation and be ready for surprise flare impacts at any moment. In 2021, Proxima Centauri unleashed a massive flare, hundreds of times stronger than any flare recorded from our Sun. Scientists are worried that with such chaos, even if Proxima B once had an atmosphere, it may have been stripped away. Any water it had might have long since evaporated. So, although it lies in the so-called habitable zone, its environment, so close to a volatile star, might be extremely inhospitable. Unless it's incredibly lucky with a thick atmosphere and a powerful magnetic field, strong enough to shield it from radiation up to 500 times Earth's intensity, everything, from its atmosphere to its oceans, and even DNA-like molecules, could be destroyed. But does that mean life definitely can't exist on Proxima B? Not so fast. Scientists weren't ready to give up. They ran simulations on supercomputers and found that rocky planets orbiting red dwarfs might not be completely hopeless after all. They input all kinds of possible conditions for Proxima B and found that, with a bit of luck, if it was born with an Earth-like thick atmosphere and a strong global magnetic field to block most of the radiation, then, even while tidally locked, it could still maintain a relatively stable climate, even support liquid water. In this scenario, Proxima B might have a vast ocean of liquid water on its surface, possibly extending into its eternal night side. From far away, such a planet might look like an eyeball, with a huge liquid area staring straight at its star. The extent of this hypothetical ocean would depend on the salinity of the water, since higher salinity lowers the freezing point, allowing liquid water to reach colder regions. Even with high salt levels, if the atmospheric and magnetic conditions are right, the simulation still supports the presence of oceans. Taking it a step further, if the basic building blocks of life are also present, then Proxima B theoretically has the right conditions to host life. We can draw inspiration from extreme life forms on Earth, like microbes thriving in the Dead Sea with over 30% salinity. So imagining salt-loving life forms on Proxima B isn't far-fetched. Climate models also suggest other potential life-friendly mechanisms. For example, on the star-facing side, thick clouds could act like a giant parasol, blocking significant radiation. If the atmosphere and oceans can circulate efficiently, heat from the day side could be transported to the night side, balancing temperature differences and preventing the atmosphere on the dark side from freezing entirely. This might allow liquid water to persist, even in regions that never see daylight. Of course, all of this is based on ideal computer models. We don't actually know if Proxima B has an atmosphere, or water, or whether it ever had them. Models only tell us what's possible, not what's certain. But we can imagine, what if it formed with lots of water? After billions of years, could some of it still remain? Maybe it once orbited farther out from the star and only later migrated, avoiding the star's most violent early phase. Though Proxima B's environment is clearly unlike Earth's, who's to say life has to look like us?